We organized this session when we learned what Claudio García was doing with irrigation projects in Uruguay. And as a result, the rules and regulations related to soil conservation, with everything that is related to resources and production. So we discussed with the Aapresid organizers the possibility of organizing a roundtable people from INTA, from Corrientes, Entre Rios, and so we have Mr. Kurtz from INTA Corrientes. He has a PhD in natural resources, and he's a reference person in the region. Claudio García is a researcher. He has a PhD degree from Brazil, and he does research on water. And Martín Mattos is the director of the Ministry of Agriculture, Fishery, and Cattle Breeding from Uruguay, with a long track record in the public-private sectors. You have already heard the title of this session. We'd like to go from the general aspects to the more specific aspects. We will hear a presentation about the problems and opportunities in connection with irrigation and natural resources seen from the with the perspective of the province of Entre Rios. Martín will talk about the Soil Conservation Act from the point of view of the Uruguayan government, and Claudio will close describing a project that meets all these rules and regulations so that we can see how we can work based on this. We'd like to integrate all these topics. We will first have the three presentations and leave the questions to the end. So we will get your questions on our cell phones, and we hope your expectations will be met. I'd like to thank Ditmar, who was not able to come face-to-face, but he is connected virtually. So we will have Ditmar, and then Martín, and finally Claudio. Hello, good afternoon. I hope you can hear me and see my presentation. Thank you, Roberto, for your introduction, and thank you, Aapresid, for having me. Today, I'd like to share with you the situation and the outlook of irrigation in the province of Corrientes, especially emphasizing rice crop in our province. This is a crop that has the largest surface area in this province, and it's a very important crop in the northeast of Argentina. It is a crop that requires irrigation, and it supplies almost 50% of the rice that is produced in the northeast of the country. So when I was thinking of this presentation, I thought I could analyze the strengths, weaknesses, opportunities, and threats of rice under irrigation in our province. I will start with the strength. Even though this thermal gradient and the irrigation from rainfall from north to south, we have the right temperature for rice in the critical period. Here you can see the minimum, lowest and highest temperatures in the dry and wet season. And the temperature that is needed for rice is the right temperature. In the province, natural resources expressed through the soil potential are very important. And small change in land use, only 30% of Class 2 soils have changed their use. And if we go to 3, 4, 5, and 6, soil availability in terms of soil that can be used for crops is very high. Almost 5 million hectares might be used to plant crop. This is a survey we carried out. At INTA, we survey natural resources and land, and here you can see the places with the largest concentration of soils that are fit for crops, especially in this area where we have lots of rice production. On the other hand, in this favorable environment, water supply is abundant. There are 2 rivers surrounding our province with a very important water flow for irrigation. The mean water flow from the Paraná River is 12,000 to 16,000 cubic meters a second. So it is enough to irrigate a whole hectare of rice during one cycle. And the Uruguay River also provides lots of water that is used, but not as much as it might be used. On the other hand, another important area in the province gets irrigation through dams. This is a monitoring we carry out continuously at the beginning and the end of the season. This information is very useful for decision making and for farmers because there is a direct relationship between the surface area covered by water from the dam and the surface that is eventually planted with rice. So we do this monitoring in August before the beginning of the season, and we see how much water we have at the end of the season. Here you can see very clearly that during the last seasons, 21, 22, 22, 23, there was a very important surface covered by water from the dam due to the lack of rainfall in this province because of La Niña. Fortunately, the good news is that apparently the La Niña phenomena will not be so severe during this season. We also have electric infrastructure that is all right. This is high voltage supply in the province. You can see that power availability is also very important for irrigation pumps, and farmers install the right infrastructure for irrigation. So rice is a crop that can only happen under irrigation. So canals, paths, and all the necessary infrastructure is built by farmers, and we have a long tradition of this in our province. We've already seen the strength, and we will now see the weaknesses. Basically, those weaknesses come from the low use of water available for irrigation. Here we see the different districts in the province of Corrientes where irrigation through dams is carried out. You can see Mercedes, Curuzucuatia, Sauce. Here you can see the number of dams in every district. In all, we have 84 dams with water, 75 in 2023, when there was very little rainfall. But there is a study from 2013 that shows that only in those two districts there is a potential to have up to 100 dams where underusing a resource that is otherwise lost. And we lose a resource as important as water. This is in connection with dams. Now, in connection with the rivers, Paraná and Uruguay, if we survey the farms that are only 100 meters away from the shores of the big rivers, we can see that in all we have 368,000 hectares that have direct access to the river shore. But you can see there are only very few dams, very few dams for rice crops. We're underusing a very valuable resource that is otherwise lost into the Paraná River. And if we consider the same for the Uruguay River, in almost 400 kilometers of the shore, there are 249 agricultural farms that are only 100 meters away. And in all, this means 199,000 hectares that could make use of that resource. So very little use of water that is underused. Another opportunity I see is something that you already know, but I'd like to reinforce. Water is fundamental to stabilize production and yield in production systems. This is a test that was finished a very short time ago here in Corrientes, where a rice crop was irrigated only what was necessary with continuous irrigation. And you can see that in continuous irrigation, there were more plants per square meter, more grains per branch, many more grains, and reduction of yield was only 8% as compared to 34% reduced gain with minimum irrigation. Imagine what the potential to stabilize water productive resources is amazing. And we also know, because we measure this every day with satellite images, there is a direct relationship between planted surface area and the number of dams. The more water we have in the dam, the more water we can use, the larger this planted surface area. Another strength is that we have an efficient control organization. It is the Corrientes Water and Environmental Institute. Water is a resource that depends on the province. The ICAA, maybe farmers do not see it as a positive thing because it's an organization that is in charge of control, but it works very well. It has the right standardized procedures to provide the concession of water and to develop farming projects. Everything is available on the internet. There are very simple forms that become more complex depending on the environmental impact of the project. If the productive project has a larger impact, then the information that has to be collected is more complex. But I think it's a strength because it sets the foundation so that in the future we will have the basic information to reach more demanding markets. So I think that having an organization like the ICAA in the province of Corrientes that works in such an ordered manner and that uses standard processes is a strength. The weakness I should mention here is that they lack staff. I had a meeting with the ICAA director, and he told me that there are 6 people in charge of carrying out this water control, when other provinces, for example, the province in the south, has 100 people working or 300 people doing that job. So I think it's an organization that we have to support. Another strength is that rice is getting very good prices right now. There is a demand, increasing demand as a result of population growth, and also because the Brazilians did not have a very good season last year. And to conclude, I think we have some threats, especially in the province of Corrientes. We see them everywhere, but especially in the province of Corrientes in the northeast. In terms of extreme climate events, we see this over and over again in our province. We see the expansion of the Paraná River. We monitor the river every time we see these extraordinary events, and we analyze the flooding surface of the Paraná River. In 2020, when the Paraná River reached its lowest limit, and again in 2021. The expansion of the Paraná River was between 7 and 9%, but in 1998, we had an extreme El Nino event, and the surface area occupied by the Paraná River almost doubled. The expansion was 98%, which generates lots of problems which is a threat for farms that are next or close to the river. We did this analysis for Corrientes, Chaco, Santa Fe, and Entre Rios, but I'm showing only this graph in 2020. Those extreme climate events are also seen inland. We do continuous monitoring of the surface area occupied by water bodies. Province of Corrientes is a low area, and a large percentage of the surface area is covered by water. After an El Nino event, the surface goes up to 58%. That is, 58% of the province may be covered by water, and this brings about lots of problems for harvesting, for crops, not only for rice, but for other crops as well. So we continuously prepare reports and communicate this to farmers.
In this area, Corrientes has 30,000 lagoons. 25,000 of those had water, but in 2023, only 2,074 had water. They could be used for irrigation, not now. So very few lagoons kept the water. In order to finish and to conclude, I think that Corrientes has a huge potential thanks to its favorable environment. There is a sub-utilization of water, and irrigation is not encouraged. We have technologies that could be used to use the water, and we need to support the organization that rules the use of water. And we have to pay attention to the threats of extreme climate events.
Hola, hola. ¿Se escucha? Bueno.
Ditmar, thank you very much. You kept to the schedule in only 15 minutes, and really you said a lot of things in that short time. Good morning, everybody. It's a pleasure to be here. I want to share with you what are the natural resources policies. I'm talking about soil and water. Thank you, Roberto. Thank you for your introduction. Uruguay, between 1963 and 1968, economic development situation resulted in three important laws for the farming sector. The law of protection of native forest, the law for the fiscalization and control of that policy, and the law of soil and water conservation. And those who are responsible for natural resources also put in place this conservation policy. The last amendment of the soil law occurred in 1933. Oilseed and grain agriculture over 100 hectares had to be responsible for the soil and under a binding condition. So growers that have more than 100 hectares with oil seeds and grain seeds have to present a plan of soil use and management. This provides a framework to natural resources conservation. Different rotations are established to protect the soil, taking into account factors such as the use capacity of soil, management practices, crop sequence, and tolerable erosion. We have use plans for rain-fed programs, also for soils and water, and also we have plans for sustainable dairy production. Where are these plans based on this universal equation of soil loss? The factors such as rain and erosion produced by rain, the K factor, which is the erosion capacity of soils, how fragile or how strong is the soil, landscape and characteristics of the landscape slope and angle of slope, and also management, which have to do with the solutions presented by the grower, both in biomass and the control of runoff, as terraces, for example. Applying this equation, we can know what's the erosion of the soil, and we need to keep this level of erosion at a tolerable level. In Uruguay, we have a study of the soil for many years now, and so they have made maps for the different soils, and soils have been characterized. As knowledge is acquired, knowledge on soils is acquired, these erosion factors are being defined. How do these use and management of soil plans work? We use this universal equation of soil loss that was validated many years ago. Then we also have the responsibility of the agronomist that is accredited. The covered the surface covered by these kind of plants is 1,800,000 hectares. What does the ministry controls? We first control the submittance of these plants. We need to control that all growers, all farmers submit their plan, because otherwise they would be ignoring our policy. We have 96% of the farmers submitting these plans. Very few don't. Also, we have to check compliance. In this equation, in this C factor of the equation, which is crop rotation, we if there is any non-compliance, for instance, if we have the report is that they plant corn, but we identify that it's soy, the crop that is being used. That would be non-compliance. Also, we need to check that good agricultural practices are followed, that the soil is covered as much as possible across the year period. And although we do no-till, we need to detect where water runs off, especially with heavy rains. We insist a lot on detecting and identify the natural drains and try to check that these natural drains don't remove or don't disturb the soil. After 10 years of the implementation of soil use and management plan, the farmer, we have developed a digital platform, so the farmer makes a sort of drawing where farming takes place, and they give data that gives us information about the erosion capacity, the kind of crop or crop rotation, and also we can have information about the possible runoff of water. We also have plans that have to do with agricultural information, which is an umbrella. They use different information systems: information about natural resources, soil, water, information systems on climate, and information system on the production system, forestation, livestock, or agriculture. Next year, we are going to implement the European protocol for agricultural products coming from deforested fields.
Los distintos productos que generan.
This verification helps identify deforestation-free products. We also developed a plan that allows us to update the factors of this equation. We are working in the relationship between crop rotation and soil management. This will be part of our policy. This possibility of crop rotation in order to tolerate erosion, we will know whether that rotation system is fixing carbon as being neutral or it is losing carbon. We will also try to find a way of farming that would reduce winter fallows, increasing the rotation that include perennial pasture and increasing cover crops. Also disseminating or communicating on good agricultural practice, not only as relates to soil protection, but also including reference to good agricultural practices. How do we control these things? This is controlled with satellite images. We present the layer where farming is conducted in the country, and from that GAPinet information, we send the results to the different regional offices, and each of these regional offices will go to check in the farm this identified information. In 1968, the law of soil and water conservation was passed. It was of national interest, that is protecting ground and underground water, surface and underground water. Two figures resulted from this, which are very important: the irrigation associations and the irrigation operators. In spite of this, in cereal farming, the irrigated area didn't increase, but this is very much used in rice crop, because there's no crop if there's no irrigation in the case of rice, and this implies operating and working on the irrigation operation. And this is something that falls under responsibility of rice industry. What is the interinstitutional management? The farmer that wants to irrigate applies for approval for irrigation, taking into account the amount of water they need. And the INAWA, which is the water authority in the Ministry of Environment, authorizes or approves the use of public water for irrigation. The INAWA decides whether water is available for that. Technical standards on irrigation water use, they are established by the Ministry of Livestock, Agriculture and Fisheries. And what has been the evolution of the irrigation area in Uruguay? The rice has 70% in the east and 70% in the northeastern, with basalt and heavy soils, but with a different topography. Some 160,000 hectares of rice have been irrigated. Spraying irrigation, spray irrigation grew from 2007 today. Now we have 65,000 hectares, but this is growing. Sugarcane, about 8,000 hectares, and vegetables and citrics, about 25,000 hectares. What has been the input of private equipment and accumulated area? The revenue task increases, and so this increased or extended the period during which the companies can manage this agricultural revenue tax. And so this increases both in the number of pivots as in the accumulated area. We see that in 2022 there is a peak, and this has to do with the value of commodities, because if we think that task exemption works as a promotion of irrigation, this exemption implies interesting values, and so it speeds up the investment in private equipment. We are working on a program for irrigation development. It's clear that this does not result in higher production, but also it results in more stability and more knowledge. And it gives us the possibility to have impact in any kind of production, not only agricultural production, when that agricultural production is integrated into other supply chains, the poultry production chain or the livestock chain or the other and in the dairy chain, dairy products chain. In Uruguay, we are concerned with training experts. We need to become more aware about the importance of irrigation. We need to create more infrastructure. Also, there are fiscal benefits and tax exemption programs. This program of the investment loss is being used only by a part of the agriculture sector, only those who pay the sales tax, and other farmers that do not pay for the sale of agricultural property are not included. So we are considering the promotion to be extended to people who pay sale tax, but also to include those that pay for the sale of agricultural property. We need to be more targeted when we present this possibility, the people who want to apply for this benefit, for this promotion. We are considered a more targeted kind of promotion. What are the expected results? Higher crop yields, stability in crop yields, more irrigation, mainly for corn and pastures, and to increase the consumption in other chains. The action would be to build technical capacities, to improve the irrigation cluster, to improve suppliers, to improve the cluster of experts. We are walking along this path. We hope that we increase the areas under irrigation, and we expect that this is done in a sustainable manner, taking care of our natural resources.
¿Tienen la presentación ahí hoy? Gracias.
Good morning. Thank you for having me, and thank you, Roberto, for organizing this session. I'll be brief since Martín has left me very little time, so you will have to pay for my dinner tonight. Based on what Martín has just shared with us about the development of soil land uses, I will share with you a case study about the experimental station where I'm working. This is in the south of Uruguay, and I will describe the plant and what we do. We have different water sources. Here I'm showing water taken from a lake, small lake. This started in 1996, and all farmers in the area were invited to participate with INIA, and only one neighbor accepted. We're still working together today. Basically, it's a very simple system. It's pumping from that lake. There is a pipeline going to 3 polars that fill it with water, sweet water during winter, because in summer we get also salty water, so we have to stop pumping. And this is where fruits and vegetables are produced. So farmers irrigate vineyards. projects have to be renewed every 10 years when you're working with surface water, since this is water from a stream, we have to do it every 10 years. You also have to be enrolled in the Ministry of the Environment, the Ministry of Agriculture, Harboring and Fishing, and we are liable from a criminal and civil point of view. In the past, there was only civil liability, but today there's also criminal liability. So when you sign, you have to make sure that the farmer will comply with all the rules and procedures. And every year before May 31st, we have to sign a sworn statement saying how much water was used and how much water was reserved in that dam. So every year you need to submit a sworn statement about how much water was used. There is strict control all over. This is the experimental station. It's a 400-hectare plant, and the ministry requests several values such as infiltration, available water, type of soil, etc., similar to what Martín said. By default, there is a very detailed study covering most of the country in a scale of 1 to 1 million. In some cases, we have it at smaller cases, so we present local data. These are inputs that are checked by those who review these plans. And here you have different areas. For example, soil, the plots that will be irrigated, and you also need to state who is the owner. This has to be signed by law. We need to know who the owner is. We also need to submit the legal relationship with the landowner every 5 years or every 10 years, depending on each case. The volume in cubic meters and authorized volume in our case, several times over these 30 years, we've been requested to increase volume. Our authorization is 19 millimeters per second to pump during 24 hours. But we cannot request a larger flow because there is no more water in the stream, and the Ministry of the Environment reserves 1/4 of the flow for an emergency or for water for animals in case of a drought. So as Martín said, there are some water streams that have no longer the necessary flow, but in all cases, you need to detail very precisely what you're doing so that there will be no issues with the project and with the numbers that are eventually checked by the technical people. In the program, the erosion program prepared by the ministry, you see the methodology presented by Martín, where you have all the factors, type of soil, coefficient, and you have the minimum tolerance, minimum soil tolerance. And here you have to suggest an improvement in rotation. Usually in our case, we're allowed a tolerance of 7 tons per hectare year. That's soil loss. If it's greater than that, then you have to see what else you can do. Here you have the different components, different years. We presented our program over 5 years, and it's usually fruits, so there's no soil movement, and grassland is used, and between the trees, so erosion is very low, and the agricultural area is quite small. But anyway, this has to be done by all farmers, as Martín said. In the case of farmers having over 50 hectares, if there's irrigation, they have to do it anyway, regardless of their plot size. This is the form they have to submit. It has to be signed by a civil engineer if the dam exceeds 5.5 meters in height. And this has to be signed by all the professionals involved. And this is submitted to the Ministry of Agriculture and to DINAWA, which is the Ministry of the Environment, that provides the final authorization to authorize the project during the time certified in the form. This comes back, but it's always subject to the submission of the sworn statement. And this is how you close these projects. In our case, just like big farmers, we're always under scrutiny, so we, public or research organizations, are always controlled. Inspectors come not always with prior notice to make sure that we're not taking water that should go downstream. Crops are controlled, the type of irrigation you declare. And in the case of this project, the deadline is December this year, and in July we already start to get notifications to start formulating the project so that we can submit everything in due time. Because if you are not careful enough, water may be allocated to others, and here you may have quite a significant issue. I know I was quite quick, but if you have any questions, I'll be happy to answer them. I'd like to thank the organizers for having given us 10 more minutes to close. There are 2 questions for Ditmar that we will send to him, and we will send him the phone number of the person who asked the question. It's mostly related to rice crops and crop rotation. For the sake of time, we will send these questions to Ditmar for him to answer later. And there was also a question for Claudio. Is there time to read questions? There's no time, so we'll also give him the phone number of the person who asked a question.